This is the main menu for the TouchPrint Essentials model. As you can see, very simplistic in nature. Some of the production statistics are shown, along with some visual graphic indicators showing current status of paste conditions, boards per hour, things of that nature. We try to make it very simple for the operator to understand. This here, we're in the setup portion. Once again, we have chuck setup, vision setup, squeegee setup, and of course stencil wiper setup. Again, a single level menu system. Recipe panel, same as previous products, very simple to use. Full board online diagnostics, gantries, stage axes, the print head, and the bottom side wiper are also covered here. Some basic functionalities. For runtime manual selections, you can choose to leave the step edges on the PCBs for leveling, or you can take them off, and we'll show you a cycle of that later. Different modes. One mode that we are particularly proud of is the actual speed selection. This function, patent pending by Milara, is used to control the overall machine speed based on the takt time of the actual process line. We've developed printers over the years that were basically designed to run as fast as mechanically and electrically possible. Well, if you have a slow takt time on your process line, Milara figures, why hurry up and wait? So what this auto speed function does is it measures the takt time. It does a algorithmic process that takes the time it measures and spreads it across the high-speed axes, thereby slowing them down proportionally to the measured takt time of the process and relaxing the high-speed axes. Once the system senses that the process speed has increased, then of course all the high-speed axes, which include the Z stage and the overhead flying camera gantry system, are sped up to maximum, and then the measuring process begins once more. Again, very simple, but as we can see, well needed. So this is a basic operation during runtime. As one can see, the alignment process of the fiducials. Status, obviously, of the machine as it's running. And now the bottom side stencil wiper is going to cycle through. We can shut that off for now. And again, it's very, very, very simple. Very simple process. We'll just change the frequency down to 0, and thereby shutting off the wiper function. Full onboard runtime diagnostics. Logging is also transpiring, such as background functions that the operator really doesn't need to know about. However, in the event of troubleshooting, this greatly expedites problem symptoms. What you're seeing here is a machine in the initial test phase on the production floor, and what you're witnessing here is the board loading into the machine. It is being clamped, inspected, and then presented to the stencil for print. Post-print, snap off, and then of course the board is then sent back out to the operator or passed downstream. What you see here, this is our look up, and look down dual camera vision inspection system employing digital progressive scan technology. The machine overall control is a complete intranet. Everything is all networked into a centralized hub. And Milara was the first to utilize GIGI PoE camera system. So again, what you're seeing is the inspection process with the high-speed linear servo gantry system. Typical feed rates are can be in excess of 3 meters per second with accelerations approaching about 4 Gs. This is an initial burn and test phase for the machine in our production area. And just going through a dry cycle case. This is one of the initial phase construction stations for the TouchPrint Essentials model. We've decided to take all the clothes off and show you pretty much what's inside. What you have here is the industrial computer with smart backup UPS control system. This is the Intranet Gig-E PoE network-based switch. Over here are the digital Delta Tau GeoBrick 8-axis controllers. There's up to 16 axes of motion control on the machine. Everything is for rigidity purposes, mounted on a 3/16 3-inch solid tubular structured frame. Everything from that post up is mounted onto a polymer cast. And of course, the advantages of polymer cast is vibration dampening. It's far better than cast iron, far better than aluminum structures, etc., etc. This is the real weight aspect of the machine. Our stage axes, this is the critical axes that are involved in the alignment process. X, Y, theta, of course, Z lift. And then from this point on, over into the next bay area, as you can see, is where the servo gantries and the wiper and the inspection gantries are mounted on the machine. A more mature state, functional assembly cell. At this point, you can see the bottom side wiper system is mounted to the main overhead gantry. The stage assembly that is used to align the circuit board is a bit more mature. It now has the conveyor system mounted. This is the print head servo gantry system, in which the camera gantry will be mounted to as well.